Objective 6 is recognizing the equations of horizontal and vertical lines. So most lines that you will graph will be in two variables, 5x minus 2y equals 6, or something along those lines. So something where the a and the b are not 0. But technically, even if a or b are 0, it can still be a linear equation in two variables, which is kind of weird. So if you look at an equation like x equals 3, it's missing the y. Now, in chapter 1, I would have said, okay, well, if x equals 3, this is a one-dimensional answer. There you go, dot at 3, done. But x equals 3 can be considered in a two-dimensional plane, which means I can add the y-axis even if the equation is just x equals 3. What that means is that no matter what y is, x will always be 3. So for example, if x is 3, y could be 4. If x is 3, y could be -3. If x is 3, y could be 0. No matter what y is, x is always 3. So if you think of those 3 points, there's a point 3, 4, there's a point 3, -3, and there's points all the way in between. So in a two-dimensional plane, x equals 3 is a vertical line through x equals 3. So this is the equation of x equals 3. Okay, in a two-dimensional plane. So again, a dot on the x-axis is a one-dimensional answer. To show x equals 3 as a two-dimensional answer, you draw a vertical line. So if I wanted to graph x equals -5, again, no matter what y is, so whether it's 5 or whether it's 0 or whether it's -3, right? X is always -5. So you'd have this point -5, 0, -5, 5, -5, -3. No matter what y is, x is -5. And so again, it's a vertical line through, oh, it's not going to let me do, darn, 1 second, sorry. As soon as you draw one line, it kind of gets confused when you try to do another. There we go. Right? So this one's a vertical line through x equals -5. And the only thing they can do to kind of mess you up is put the number on the other side. So if I ask you to graph x plus 2 equals 0, you'd -2 and say, hey, x equals -2. So wherever x or whatever y is, x is -2. So I usually put a dot at -2 and I just draw a vertical line. So I'm going to go like this. There we go. So this is my graph of x plus 2 equals 0. This is my graph of x equals -5. And this is my graph of x equals 3. So if x equals a number, then you get a vertical line which passes through the x-axis only. When x equals something, you do not pass through the y-axis. All right, so now we're going to do the same thing with these lines. What if I get rid of the x value? So what if I have something like y equals 4? So here's y equals 4. The question is, should I draw a vertical line or a horizontal line? Well, if y always has to be 4, then no matter what x is, y will always be 4. So if you think of these 4 or 3 points, -3, 4, 0, 4, 3, 4, I'm going to draw a horizontal or vertical line. Horizontal! So I would draw a horizontal line. Oh, it's not going to let me again. Let's see. Darn. I hate it when it does that. Okay, sorry, I'll just draw it freehand. Whoops. Maybe now it'll let me. Oh, okay. We can do this by hand. I start becoming a perfectionist. As soon as I'm allowed to use a straight line, I'm like, I like it. All right, this is y equals 4. So now I'll use a different color. So what if I wanted to graph y equals -2? Well, again, no matter what x is, y is -2. So here's a point, y equals -2. Should I draw it vertically or horizontally? Definitely horizontally. So this is y equals -2. And then lastly, if I want to graph y minus 3 equals 0, I'm going to add 3 to both sides to show that I'm actually graphing y equals 3. Where does y equals 3? Right here. And again, if I only want to pass through y equals 3, I'm going to draw a horizontal line through y equals 3. Awesome. So when I have y equal to a number, I get a horizontal line, and it only passes through the y-axis. And that is objective 6.